What do we call the center of the atom? It starts with an N. Ends with a nucleus. It's our nucleus. I know you said it. I was waiting for more people. Good job. Do you want a high five? No. Okay. So I know where my center of my atom is. Do I know where the outside of my atom is? Where is the outside of the atom? What's on the outside of an atom? My electrons. Are they sitting still or are they running around as fast as they can? Running around as fast as they can. So if they're running around as fast as they can, do I know where the outside of my atom is? No. So the only way I can find a radius is if I put two atoms next to each other. Then I know where their two centers are. And then I draw a line between the two centers. And when I cut that line in half, that's a very bad half. Here we go, here's a better half. I cut that line in half. Now I know where the edge of it is. Can you see it now? So, my definition for an atomic radii, this is plural, okay? Radius would be singular. Sometimes we use them interchangeably. The definition would be 1/2 the distance between two nuclei. Do you see how radius ends in an us and nucleus ends in an us? So the way we pluralize it was we drop the us and we put an I. So radii, nuclei. Can you see it? Yes? No? Maybe so? This sounds like Chinese? I'm not awake yet? The weather's making me sleepy? Any of these? Right? Atomic radius. The reason we talk about the radius of an atom is because it's going to tell me how... What? It tells me how...
Wait. Resay the question again?
The atomic radius tells me how...
Bigger the energy field is going?
How big my atom is. So atomic radius refers to the size. You were so close. And yet so far. So... we use the size of the atom. This is how we determine every other thing the atom does, is by its size. Okay? So, you should have your periodic table. Please put it in front of you because we're about to go through a horizontal trend and a vertical trend and you're going to need to look at it. First thing we're going to do is read through the science words and then we're going to put it in, less science words. So we go with the nuclear force increases as the charge increases due to increasing number of protons and increasing number of electrons in the same main energy level. So it sounds like there's a whole bunch of what? What word did I say like 5 times? Increasing, right? So a whole bunch of things are getting bigger. Increasing means to get bigger. So, the charge is increasing, the force is increasing, the number of protons is increasing, and the electrons are increasing. However, this last sentence says, this force pulls the electrons closer to the nucleus, resulting in decreasing size. So I have a whole bunch of things that are getting bigger, and yet my atom starts to get what? Smaller. So let me show you how this works. Here's my little whiteboard. I have in my nucleus 1 proton. I have in my energy level 1 electron. When I had a hula hoop that I had in my classroom. It hung on the wall. It was really neat. It was known as the energy level hula hoop. Okay? I would put one kid in the middle of it, and I would say, all right, with one hand, squeeze this hula hoop as tightly as you can towards your body. I want you to imagine squeezing a hula hoop in towards your body with one hand. How well does it work?
Not well, because...
Can you squeeze it into your body with one hand? No. So if I only have 1 point of attraction, how close can I hold this hula hoop to my body? Not very close. On this same energy level, I could also put a second electron. That's when I move from hydrogen to helium, as well as I put a second proton in the nucleus. So now I have a second hand. Which one can you squeeze closer to your body? 1 electron or 2 electrons? 2 electrons. I can squeeze it in closer because how many things do I have squeezing it? 2 protons. So the more protons that I have on an energy level, the more hands that I can use to squeeze this hula hoop in closer. Can you imagine that in your head? What if we look at this energy level out here? Because we can only put, we can only put 2 electrons on our first energy level. How many can we put on our second energy level? Pagets, periodic table. And then I've kind of taken over your table. You'll need to sit at another one today.
Okay.
How was testing? Do you have a pass?
Sorry.
Thanks, buddy. How many electrons can I put on my second energy level? 8. Okay? So I'm going to start with, here I'm going to change my colors so it's easier to see them. I got 1 electron here, and I'm going to add 1 proton here, and here's my attraction. So 1 hand hula hooping. Then I'm going to add another electron here and another proton here. Which one's going to be tighter, 1 hand or 2 hands? Which one is going to squeeze closer? 1 hand hula hoop or 2 hands on a hula hoop? I would like you to squeeze a hula hoop with 1 hand, please. Does it work? No. So which one's going to squeeze in tighter, 1 hand or 2? 2. Now, on this next energy level, I can go up to 8 protons. So here's a third one and a third electron. So now imagine you have 3 hands squeezing this hula hoop. Which is going to be tighter, 2 or 3? 3. Let's put a 4th one on it. Who's tighter now? 3 or 4? 4. So the more protons I add, okay, I could go all the way up to 8, right? And each one is going to be attracted to the nucleus, to that proton. So imagine 8 hands on a hula hoop. Could you squeeze it in pretty much like on your body by that point? It's going to be the smallest hula hoop you ever seen if I got 8 hands pulling it in towards me. Right? I'm going to break it. Right? That's what happens. Every time I add a proton and an electron in the same level, so that's the same row on your periodic table, I'm able to pull everything in closer to me. So the more protons I have, the more I can squeeze and love my electrons and hold them so close. Can you picture it in your head? All these protons. I love you, electron, and you, electron. And he pulls them in so tight. Okay? So if we look at our periodic table, I want you to find the second row. The first on the left in your second row is which element? Lithium. And the last one on your second row is which element? Find number 2, go all the way across. Where are you at? What element? You're not even looking at your periodic table.
Dang
So we got lithium, right? Lithium's over here. Who's down here? Neon. How many protons does lithium have? It has 3 protons. How many protons does neon have? 10. So lithium can hold on to his hula hoop with 3 hands, and neon can hold on to his hula hoop with 10 hands. Who is going to squeeze it in closer? Neon can squeeze it in closer because he's got how many hands? 10. So when we look side to side, we look at the number of protons. Okay? More protons, more squeeze. Here's how we're going to remember this. Put your arms out. You're going to say more protons. Say more protons.
More protons.
More protons, more squeeze. Say more squeeze. Let's do it together. Are you ready? More protons, more squeeze. Now you do it. Excellent. So, what we're going to write over here is more protons equals more squeeze. This makes my atom get smaller. We're going to think hands on a hula hoop. Unfortunately, my hula hoop died. RIP, May 28th, 2017. Somebody squeezed it way too hard. So, if you look at your periodic table, which side has the biggest atoms? The ones on the left or the ones on the right? Who has more protons, the left side or the right side? The right side. So if the more protons make it smaller, who's going to be bigger? If I add more protons and that makes it smaller, who's going to have the biggest atoms? The left side or the right side? The left side is going to have more protons. So I'm always going to start on the left with the big ones and get smaller as I move to the right. On your right side, those are your teeny tiny little, I'm going to squeeze this hula hoop in as close to me and love all of my electrons. All right, so now we've got our side-to-side practice. We're going to do our up and down practice, or our vertical practice. As electrons are added to higher energy levels, which are farther from the nucleus is unable to overcome this increased charge. Also, the inner energy levels shield the outer electrons from the attraction of the nucleus. These obstacles result in increasing size. That's a lot of words. Let's go back to our picture here. Our electrons with their attraction drawn. This is neon. It has 10 electrons on it. What if I wanted to move from neon to sodium? I would need to add another proton, right? Because sodium has 11 protons, but sodium also has what? 11. Do you have a pass? Excellent. Periodic table packet. Taking notes. All right. If I want to change from neon to sodium, neon has 10 protons and 10 electrons. Sodium has 11 protons and 11 electrons. So if I've already filled up, this is 10, what do I need to add in order to make it 11? I need to add another ring, right? So that I can add another electron. And I draw my attraction. What happened to the size of my atom when I added another ring? What happened to the size of my picture? It got what? Bigger. Because I had to add another what?
Ring.
Another ring. So could you say that every time I add another ring, it gets
Bigger, yeah.
All right. Do you think that, let's say you have 3 hula hoops, okay? And you got all of the hands you need to hold the first 2 in. Do you think it's going to be as easy for you to squeeze that third one in as tight? No, because what do you have in the way? You've got 2 other hula hoops in the way, right? So do you think my attraction, do you think my green attraction is the same as my blue attraction? Do you think my green attraction is as strong? Or do you think my orange attraction is as strong as my green attraction?
No.
No? Do you think my orange attraction is as strong as my blue attraction?
No.
No? So not only do I have things in the way here, but it's just so much further away. Who am I going to be able to have a better conversation with? Jonathan or Jose? Why?
Because he's close to you.
Because he's closer to me, right? Jose, he's still part of my class. I still love you, bro, right? But you're just so far away. There's all these other tables in between us. Right?
Yeah, okay, yeah.
This is what happens in my atom, right? I'm the nucleus. Here are all my energy levels. Can't have a good conversation if there's all these other people in the way. They're going to be trying to join in, right?
I mean,
I could yell, which is what our atoms do, right? They still have this attraction. They're still holding on to it, not flying off into space.
I'm going to send you a picture with a letter.
It's good. It's good. I like it. So, not only when I add more rings, I'm getting bigger, but there's crap in the way, right? Every time I add a ring, I got to deal with all the other crap that's in between us. Because, what if I filled up all of these tables and we had another kid join the class? What would I have to do? Add another table. Am I going to be able to talk to that kid, or are they going to have to go through all of the other tables to get there? Why are you raising your hand? What do you want? Oh, I want $1 million. Which one of us do you think is going to get their dream?
Not you.
All right, so here we go. Arms in close to you. Arms up, in close to you. Here's what we're going to say. We're going to say more levels, more size. More levels, more size. As I add more levels, what do I get? More size. So, here we go. Here we go. More levels. Equals more size. So my atom gets bigger. Once you get that written down, I want you to look at your periodic table here. I want you to look at these numbers down the left-hand side. Do you see these numbers down the left-hand side? These are called what? Starts with a P. Ends with an period.
Period.
These are my periods. These are also my rows. These are how I count my rows. Guess what else they count? They count my energy levels. Hydrogen and helium only have one hula hoop. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, they have the first hula hoop and a second hula hoop. Which means on my third row, how many hula hoops? 3 hula hoops. Every time I go down a row, guess what I'm adding? Another level, another ring, another hula hoop, another reason I'm getting bigger. So who is the biggest one? The ones at the top or the ones at the bottom? The ones at the bottom. What is the max number of hula hoops I can have? Did you just say 3? Did you want to hold up your other hand to help you out with that 3? What's the max number of hula hoops I can have? 7. See these numbers here? 1, 2, 3, 4, 5, 6, 7. The biggest number down at the bottom is 7. So the most hula hoops I can ever have is 7 hula hoops. Excellent. So, I am going to get bigger from the top. These are my tiny, tiny top ones to my big, big bottom. Tiny top to big bottom. Tiny top to big bottom. I got a pear-shaped periodic table for the ladies that know what a pear shape looks like. It's got a tiny top and a big old bottom. All right, before I scroll down, I want to try some of these practice problems. Practice! So, we're going to circle the larger atomic radius. So I'm going to find the bigger or the smaller? The bigger. So I'm going to take 2 fingers, because I got 2 elements, put up 2 fingers, and I'm going to put one on lithium and one on fluorine. Did you do this? Are we looking at a side to side or an up and down? Side to side. So when I look side to side, that's the top box. It says when I have more protons, I'm going to get more squeeze. So if you look at lithium, how many protons does he have? 3. If you look at fluorine, how many does she have? 9. Who has more squeeze? Fluorine. So who's going to be bigger? Lithium. Fluorine is going to hold everybody so close. Lithium's like, yeah, I got a hula hoop. It's here. All right. Fluorine is like, I love my hula hoop. It's my favorite. I'm going to love it and squeeze it and hug it and cherish it and marry it and love it. Yeah. So who's going to win? Lithium or fluorine? Lithium. All right. We're going to try the rest on your own. 2 fingers. Put them down. Decide. Side to side or up and down. The last one, E, this one right here, you're going to have to use both. Both. Yes.
Wait, so what if they're both under each other?
If they're both, you have
Or
to.
It won't under each other.
Oh, then use the top to bottom one. The vertical, the second box. If I put 1 finger on tin and 1 on strontium, what am I looking at? Side to side or up and down? Side to side. So I'm looking for most protons or least protons? More protons makes it smaller. Least protons makes it bigger. So if I look at least protons this size, is that going to cut out a step where I have to think about, all right, more protons squeezes it, so I need to pick the other one. What if we look for least protons? Who has the least amount of protons? Who loves their hula hoop the least? Strontium, because he has how many? And tin has 50. So 38 is less love. I don't got enough love for you. Next up, sodium and rubidium. 2 fingers. How come you're not doing this with us? Sodium and rubidium. Are we looking side to side or up and down? Up and down. What happens as I move down? What am I adding every time I move down a row? It gets bigger because I'm adding another ring. So who's got more rings, lithium or rubidium? Rubidium. How many rings does he have? 37 is protons. Look at the number to the left. 5 rings. How many does lithium have? 2. Lithium has 2 rings. Okay? Which is bigger, 2 or 5? Which is bigger, 2 or 5? 5 is bigger. 5 rings is more bigger. So, rubidium wins. Helium and xenon, 2 fingers. Who's bigger? Xenon. Why do we know xenon is bigger? Because he has more rings. How many more rings does he have? 5 more rings. Good job. You guys are getting it. How many rings does helium have? 1. How many rings does xenon have? If you go all the way back over to the left, xenon has 6. Xenon wins. Next one up, barium and nitrogen. Put your 2 fingers down on your periodic table. Barium and nitrogen. Who has more rings? Barium or nitrogen? Barium has 6. Nitrogen has 2. So who do I know is already going to be bigger? Barium. There's a really silly chemistry joke. It says, what do you do with a sick scientist? And it goes like this. If you can't helium and you can't curium, you might as well bury him.
I get it.
Do you get it?
Yeah.
All right. Underneath. We've got arrange in order of increasing size. So now I have to find 3 elements. So I want you to find technetium, yttrium, and cadmium. Can you find technetium, yttrium, and cadmium? Please find technetium, yttrium, and cadmium. Oh, did you want me to start feeling sorry for you? You don't care if I feel sorry for you? Do you care if you pass this class, or did you want to not go on to the next grade? Which one is a bigger problem? Being tired or being in a class with a whole bunch of sophomores next year? All right, did you find them? Yttrium, technetium, cadmium. I'll give you a hint. Yttrium is number 39. It's Y.
30. Oh, got it.
Did you find it? All right. Are we looking at a side to side or an up and down?
Side to side.
Side to side, my horizontal pattern. So I know all of my big ones are on the
This left.
left and all of my small ones are on the
Right.
right. So if I want to go in increasing size, I need to start small. So who is furthest to the right? Who's furthest to the right? CD. The next one up is TC. After him, my Pac-Man's going to eat Y. Do we know how Pac-Mans work? This is a less than. This is a greater than. Okay? When I was a kid, it was like this. My teacher goes, just imagine it's a Pac-Man and he always eats the bigger one. Okay? Nom, 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 nom. So you change him, you point him in the direction where this is the smaller. And he always goes to eat the what? He always eats the bigger one. So it's butt small, mouth big. Okay? So, beryllium, magnesium, and calcium. Find those three. I need to find the smallest one. Which one is the smallest? First off, what pattern are we looking at? A up and down or a side to side?
Up and down.
A up and down pattern. So where are my small ones? On the up or on the down? On the up. So who's the most up? BE. Which way is my Pac-Man going to go? Is he going to eat to the right or eat to the left? Where's the bigger one? The one we're about to write or the one we just wrote? The one we're about to write. Because we just said this was the smallest. So who's the next one after BE? MG. And then my Pac-Man eats? CA. All right, I want you to try the next two on your own. Here we go. Let's go through them. We got TE, I, and XE. Find those three. TE, I, and XE. Are they side to side or up and down? TE, I, and XE. They're side to side. So I need to find the small side to start out with. Who's the small side? The left side or the right side? The right side. The right side has more arms to squeeze my hula hoop and love it in so tightly. Please don't chunk your chocolate at me. So who's the smallest one? XE. After him? I. And then who? TE. All right. So now I've got arsenic, nitrogen, and fluorine. Put your fingers on those. What do you notice? Are they side to side or up and down?
Side to side.
Both. They got both. I'm trying to trick you because they got both. It's actually not a trick. It's where we're going to put both patterns into play at once. Are you ready?
Yeah.
First one, I have to decide who is the smallest. So who has the least number of rings and is the closest to the right? Nitrogen, arsenic, or fluorine? Well, nitrogen and fluorine both have the same number of rings, so we already know arsenic is the big guy. We'll tack him in on the end, right? We've established arsenic is the biggest, right, because he's on the bottom. So now we have to decide who is smaller, nitrogen or fluorine. Nitrogen only cares 7 times. He only has 7 loves, 7 arms to squeeze his hula hoop in. How many does fluorine have? 9. Fluorine's going to squeeze that hula hoop in 2 arms more. So who is going to be smaller, nitrogen or fluorine? Fluorine is the smallest. Nitrogen is in the middle. And we said arsenic has the most rings because he's lower. We just knocked him out pretty quickly. Did you follow it? A little? Here's a trick, excuse me, to help you out. If you will, on this little periodic table underneath, if you'll color in this guy up here and this guy down here. Bless you. This one is the smallest one. This is helium. This one is the biggest one. What's his name? Francium. So, smallest is in the upper right-hand corner. Biggest is in the bottom left-hand corner. Like this. Teeny tiny on the top.
Very big on the bottom.
Teeny tiny on the top.
Very big on the bottom.
Teeny tiny.
Very big.
Okay. So, I'm going to get bigger as I move in this direction. Do you see it? Can you picture it? Your mom. Who's the smallest?
She said that to me last time.
Who is the smallest?
Your mom.
Helium is in the upper right-hand corner. Who's got the biggest? Cesium down over here. Because my picture is too big for my screen here. So can you see how I'm getting smaller as I go across?
Yes.
Can you see how I'm getting bigger as I go down?
Yes.
Can you see it in your head now?
Yes.
Beautiful. All right, let's talk about when I'm an ion. Down at the bottom. Hey, you need more passing and less conversation. What do I call a positive ion? What has pause? Huh? A cation? What do I call a negative ion? It's just an ion. Get it? Anion? The word is anion. Superstar. Oh, is she going to help you pass? If not, put it away. Oh, that sucks for you. I can unfreeze it really fast. I got a blowtorch. It unfreezes things really fast. All right. So I have a positive ion. If I have a positive ion, what do I have more of? Protons or electrons? Protons. What do I know about things that have lots of protons? More protons, more. More protons means, look at the top of your page, more
squeeze.
More squeeze. So, when I have more protons, like say this positive charge, do you think my positive ion is going to have a bigger size or a smaller size?
Smaller size.
Very
Good job. See here, it says smaller radius. Did you actually read it? I don't know what I'm more impressed with, is figuring it out or reading the paper. Both are very impressive.
I read it right. It's smaller radius.
Okay, so what about the other one? What does it say?
Larger radius.
Okay, so if I have more electrons, I'm going to have a larger radius than my regular neutral dude. So, which way is my Pac-Man going to go in that example? Who is bigger, the atom or the ion? For my positive, my calcium, we're going to start over here. Okay? Is it going to go this way or is it going to go this way?
It's that way. That way.
Okay. This way?
Yes.
This way?
No.
Okay, but this says that a cation has a...
Smaller radius, so you would go that way. You gotta.
It's going to go this way? Billy, shut up, puppets.
So it's always gonna go on that side.
It's not always going to go that side. What you do is you have to look at the two things here and you have to see this one has 0 extra loves, and this
I
one
got
has
2 plus.
2 extra loves. 2 extra loves means 2 extra squeezy and tidy. Okay, so who's bigger? This one bigger? This one bigger?
That one.
This one's bigger. So please put this guy in the middle. So I'm gonna eat him up.
That means the other one's gonna be this way.
So if this one looks like this, bloop bloop.
Yeah, no,
Okay.
it's gonna be like that.
So this one over here. See if I can do it.
You gotta get up in the chair.
Okay, is it gonna look this way?
Yes.
Or is it gonna look
No. No.
this way?
No.
I mean, what other teacher teaches with shadow puppets?
No.
This one?
No. Yes.
Why?
Because it's larger and they got an extra.
He's got extra hula hoop. That's like, let me make this hula hoop even harder for you to hold. I got a whole bunch of extra electrons on it. So I want you to do 1, 2, 3, 4 down below. Choose. Which way is it gonna go? Edie left, Edie right.
It says the largest.
Circle the larger one.
It's gonna be plus 2.
Here we go. This says circle the largest atomic radius, but I said I want you to try it with the less than and greater than. Yes?
Yes.
All right. So I got lithium and lithium plus.
Go this way.
So what's he going to look like? Is he going to look like this? Is he going to look like this?
No. No. The other side. Oh, yes. Yes. That's it. That's it.
Why is he this way?
Because
Lithium plus is bigger?
Yes. You got a plus 1. It gets smaller.
More plus means more small. More plus is more small.
No, miss. Oh, yeah, you got it. You got it.
It's too big.
I'm gonna scoot up. Scoot over.
I'll just eat the whole problem. All right, so let's try 10, 10 2 plus, 10 4 plus. Who's got the most love? Regular 10, 2 plus 10, 4 plus 10. 4 plus 10 has the most love. So if he's got the most love and he's going to squeeze them in so tight, who's going to be the smallest?
Huh, wait, what?
Who is the smallest? Because he loves and squeezes them so tight. 10.
No. Yeah.
4. He's got 4 times extra love. Do you see it? Extra love means extra small. More plus, more small. So then we got 2 plus and regular 10. Who is smaller? 2 plus or regular?
2 plus.
2 plus is smaller. What about fluorine and fluorine negative? Who's smaller? What? Who's smaller, fluorine or fluorine negative?
Fluorine negative.
Just fluorine is smaller. Negative is a whole extra thing on my hula hoop that's going to make it difficult for me to handle. So a lot of you are getting them backwards. You got to remember, more protons, more squeeze. Less protons, less squeeze. So this last one, which way is he going to go? Is he going to eat the right guy or eat the left guy?
The left guy. No, the right guy.
He's going to eat the right guy.